The sun has graciously decided to shine upon us. Hello there, it's Lawrence here. So the last video that I did concerning the final experiment has produced a couple of questions which I want to answer. So just a brief recap. This is the continent of Antarctica, a land mass covered mostly by snow and ice with mountains sticking out. And the final experiment are going to be located, going to travel from Ushuaia or Punta Arenas in Chile, probably from Punta Arenas, and fly 1,300 miles or so down to Ellsworth Mountains. Excuse my dirty fingers, but our power went out today and we had to get the generator going. Anyway, there's the Ellsworth Mountains, located about, in this case, about 80 degrees south. And to get your bearings, this is the prime meridian that goes to Greenwich on a 0 degrees and then 180 degrees around the other way. One question I had was, well, the Transglobe expedition didn't perform across Antarctica exactly the way I wanted it to, which in fact they did. They went down the 0 degree longitude line from the coast, skidoos, motor toboggans, snow machines, whatever you want to call them, and went from here, started off at Borga, and then all the way to the South Geographic Pole, where Scott Amundsen base is, and then down the other side to Scott base, which is on the other side here, and then joined the ship and went up the other side. Anyway, final experiment's going to be down here, and it's about 80 degrees south. And that, up to a few years ago, gave us problems as far as communication is concerned. In my old days, in 19 expeditions I was doing from the 1970s through to 2000s, there wasn't satellites that went around the Earth this way that covered the Antarctic very well at all. Starlink does now, Iridium does. They have orbits that are highly inclined and are able to, with handheld satellite phones, you can now talk to anywhere in the world. But when I was down there, we had to use shortwave radio. And this unit here is a radio shortwave SSB transceiver that uses the ionosphere, which we'll come to in a second, to talk back to Scotland from Antarctica. We're based at 80 degrees south, and we had a radio link from Patriot Hills near Union Glacier all the way back to Bonnie, Scotland, to just north of Aberdeen. And it's a very lightweight transceiver, weighs less than a kilo. For its time, it was pretty interesting. It doesn't have an on-off switch. It's got big dials, which are good with gloved hands and stuff. But this little box here was able to get all the way back on shortwave to Aberdeen and to other locations as well. We built it specifically for our expeditions, and that worked quite well. Now, for those that remember the late great Terry Lloyd from ITN, he was a marvelous reporter for ITN. He sadly got killed in action in the Middle East. But in one of our expeditions, we managed to get him to come down to Antarctica to do a live broadcast. And that's very difficult because you need to be able to, in those days, to contact a satellite called a geostationary satellite. Geostationary satellite, I'm going to get my lovely globe. A satellite that rotates, that so far out, it's actually 6 Earth radio away, so 6,000 and a bit. If you come out 6 times as much, the satellite sits around about here, looking back towards the globe over the equator, and it rotates in the same direction, if you like, as the land beneath it on the globe. And so if you're looking up in the sky, the satellite will appear not to move over a 24-hour period. It does wander a tiny bit, and they try to keep it in a little box, but for people with TV antennas that are pretty wide beam width for, you know, watching your TV, watching your Paris 2024 in Uganda or whatever, their satellite dishes are actually pointing nearly vertically up. So if you look at pictures of Africa or people that live in on the equator side, you'll see that their satellite dishes on their roofs point nearly upwards. However, if you're in the UK, up here or down here or wherever you want to be, you'll find that the satellite dishes are pointing more and more towards the horizon because the elevation of the satellite there is lower in the sky. Now, hopefully you get a satellite that's on the same longitude as you are, that's sitting out here. You have the highest elevation. If you're off to one side over here, the satellite elevation is a bit less. Anyway, so that's geostationary satellites. Still used now for weather and still some, obviously for communications purposes, still used nowadays. There's obviously fiber optic cables hanging around, but still pretty good. Anyway, in those days, we set up the microwave satellite dish at Patriot Hills, got the best locations we could on base, and then during the daytime, the satellite actually produces a figure of 8 movement in the sky, and your satellite appears for just a couple of hours, and it literally rises above the northern horizon, and we can actually communicate with the satellite, send the live feed or the data feed for Terry, so it could be broadcast on ITN TV. And we did that, and we were really pushing it because 80 degrees south is, as far as the satellite's concerned, is as far south as that you can see them. Beyond that, they actually are beneath the horizon. If you choose a satellite that's on the same longitude as you, that's about the best one. It'll be the highest elevation. But if you choose an elevation satellite that's on a different longitude from you, it would actually be lower in the sky. It actually produces an arc. Oh, look, there's a mountain, and I didn't manage to find a penguin, but anyway. So that's geostationary satellites. You just can't, if I'm sitting out here at 6 Earth radios away with my geostationary satellite, I just can't see, there we go, I just can't see the polar regions above 80 degrees north or south. So that was one of the questions I had. The second one was the differences of why the North Pole is slightly flatter than the equator. It's oblate spheroid. The Earth rotates, it produces centrifugal forces, causing the center bit to bulge out a bit. Not a lot, but it is not easily visible because the bulges are quite small. But to give you an idea, if you're at the North Pole or the South Pole, the horizon is actually a bit different. In the equator, the horizon, if you're standing on the beach at eye height, the horizon, looking out towards the horizon, there's a nice little ship going over the horizon there. It's about 4.409 kilometers away. But in the polar regions, because it's flatter, the actual horizon is actually closer to you by about 8 meters. And that actually can have effects on that on the satellite links concerned, because you want your horizon to be as clear as possible. For microwave links, the curve of the horizon is very important to us in the communications world. And when we're designing a microwave link to communicate from one location to the other, we have to take the curve of the Earth into the calculation, and then the curve actually varies depending on where you are in the world a little tiny bit. Tend to use a standard number, but when we actually do design a link, we want to talk, say, from this location to this one, and we can't because the Earth gets in the way. So we have to put intermediate relay station that sort of is high, so it covers, it's able to see this radio tower from its location, avoiding obstacles in the way. So you may have trees and buildings and mountains or hills, but one of the largest obstacles is actually the Earth itself. in the way. That's why you have relays. You can get maybe between 2 microwave stations at reasonable height, a distance of 30 to 50 miles before you have to do another hop. And the reason for that is you basically go over the horizon and the Earth gets in the way. I think the longest one I know of is around about 200 miles, and these 2 locations are about 8,000 feet. So that actually does change things slightly in the Arctic and the Antarctic a bit when we do our engineering. What else is happening? Oh yeah, geostationary satellites. Again, I've just thought about this. So if you want to get your Apple iPhone or your Samsung, and at night, if you're in the northern hemisphere and you're in a nice dark area, is take time exposure of whatever you can do, maybe 20-30 minutes, and point your camera due south. Not only will you, and you hold the camera or get it so it's nice and stable, and you'll get star trails as the Earth rotates at 1 degree every 4 minutes or so. The stars will produce an arc of some description. But if you're very lucky and you're looking directly south or either east or west of south, you actually find some dots of light that don't move. And those are the geostationary satellites that are up there. So that could be cool. And you also see that the star trails are going to be at arcs. And the same for the, if you're down the south here, you point your camera north. What else is going on? Right, yeah, okay, yeah, so there's geostationary satellites, yeah, there we go. Earth's radius, roughly 6,378 kilometers, the equator. There's that satellite dish in Uganda on the equator, pointing straight up in the sky vertically to talk to or watch the TV signals coming from this lovely satellite up here, as well as if you're in Aberdeen or London, or you're in Johannesburg, or you're in say Melbourne. Your satellite will be pointing, dish will be pointing at a lower elevation towards the sky. One of the other questions we had to do was the what will and all the lovely other people that are going to be traveling to the base camp here at Union Glacier Sea as far as the 24-hour sun is concerned. Will it actually be visible for 24 hours? Well, there are mountain ranges all around that area. The mountain close by, within 5 miles of the camp, rise to some 6,000 feet above sea level. Base camp itself is at about 2,300 feet above sea level, and the mountains rise to about 6,000 feet above sea level. So there are some obstacles on certain bearings. If you look around 360 degrees, there's ice rises. You're on a glacier which is rising or falling depending on which way you're looking, and there are mountains all around you. Some of them are fairly high and close, but the nice thing about the period that Will and the rest of the people are going to go down there is the sun's elevation is pretty high. At local midday, when the sun is actually due north, the elevation of the sun is going to be 34 degrees above the horizon. I mean, that's pretty high. It will skirt as it goes around that way, as compared with the other direction. If you're in the northern hemispheres, from east to west, looking north, it will skirt above the local mountains, and it will actually clear those. It clears those mountains from second week in November through to the end of January. It'll be above those local mountains. So physically, there should be nothing stopping seeing the sun apart from the weather. Yeah, that's it. So been my pleasure to go through that again. Thank you very much indeed for your comments, and really enjoy the the trip to Antarctica. And if you have any more questions, fire away. I'll try not to be longer than 15 minutes. Cheers for now.